Alright, hello everyone, welcome back to ACE IB. So, today we're going to be going over permutation and combination. So, first of all, permutation and combination are all under the mathematical field of combinatorics. Now, this field basically deals with all kind of counting problems, whether you're tallying up a total number of ways to order something, or something along those lines. So, first of all, we'll start with permutation. So, the main difference between permutation and combination is that in permutation, we care about the order, and in combination, we don't really care about the order. And we'll start with permutation because permutation is usually easier to calculate. So, let's say we have a very simple problem. There is a race with 5 people, A, B, C, D, E. Then how many ways can they finish in the race? So for examples, they can finish in the order that they are in right now, or maybe they can finish in some random order like B, D, E, A, C. So the question is, how many different ways can they finish in? So the way we do this question, and the tip with all permutation and combination questions, is to consider steps. So, since there's 5 people in this race, I will draw 5 boxes, each indicating 1 step. So, basically you can think of this box, the first one, as whoever comes in first. The second one as whoever comes in second, so on and so forth. And basically, what I'm going to do is I'm going to write how many ways someone can finish in the first box, or finish in first place. So in our case, there's 5 ways that someone can finish in first place because there's 5 people that are racing. So I'm going to write 5 here. Then for the second place, how many ways, or how many different ways can the people finish in first and second? Well, since we already placed someone at first, that person can't go in second place again. But the remaining 4 people still can. So we put the 4 here. So there's 4 ways for someone to finish second. And then we consider the next place, which is third. Now, since 2 people have already been determined for first and second, there's only 3 people left for the third place. 2 for the fourth, and 1 for the 5th place. Finally, we can multiply all these together to get 120. Now, in the case with this question, we were able to multiply them all together because these cases are mutually exclusive, meaning that if someone finished first or in one position, they cannot finish in another position. Now, this is not always the case, so you do want to make sure in your question if you can use permutation or combination. So, our answer to this question would have been 120. 5 times 4 times 3 times 2 times 1 is quite long, and when you do a lot of permutation and combination, you'll find out that a lot of times we will have to write these long sorts of multiplication, especially from one number all the way down to 1. And in particular, we call this 5 factorial. 5 times 4 times 3 times 2 times 1. So if you don't know what factorial is, it's basically multiplying that number all the way down to 1. So from now on, I'll be using this notation. Okay, now let's take a look at another permutation problem. This time, let's say we have 6 people. We'll still put them in a race, A, B, C, D, E. But this time, we only really care about the top 3 because we're going to be awarding medals. So, how many ways can these 6 people finish in top 3? Oh, forgot the F, but yes. So now we're only choosing 3. basically. So, once again, since we are choosing 3, our multiplication will have 3 steps. The first place, there are 6 different choices. Then for the second place, we will only have 5 because one person would have to be in first place. Then for third place, we only have 4. Multiplying them together, you should get 120. So, in general, we write these sort of permutation as something along the lines of 6p3. So we write the total amount we're choosing from here and how many we're choosing here. In this case, we only had 6 times 5 times 4, unlike the previous question where we multiplied from 6 all the way to 1. In general, we can represent this as 6 factorial divided by 3 factorial. Since if we write this out, we can see that the extra terms 3 times 2 times 1 will cancel out with each other and leave the 6 times 5 times 4. In general, NPR can be written as n factorial over n minus r factorial. This is not too difficult to remember because you have kind of n choices that you're choosing from, but if maybe you're not choosing all n, you want to get rid of those r choices before them. Okay, so now let's talk about combinations. So permutations and combinations are essentially very similar, except combination does not care about the order. So if we go back to that previous example, if we still have 5 racers, A, B, C, D, E, and F, this time maybe this is a qualification race. So instead, 3 people will qualify to the next round. But we don't really care about exactly what place they come in, first, second, or third. In this case, we only want to choose 3 people out of these 6 people, but we don't really care who's first, second, or third. So the way we do this is we can first write NPR, or in this case, it would be 6p3. Then we want to get rid of the duplicates. Let's say that the 3 people that qualify are A, B, C. Well, there are a few ways that they can finish in top 3, particularly ABC, ACB, BAC, BCA, CAB, and CBA. So, since the case ABC qualifying is counted a total of 6 times, we want to divide 6 from 6p3. And in particular, we write this as 6c3, or 6 choose 3. Some other mathematics books might also represent this like this. So, just to keep in mind if you ever see both notations. I believe IB mainly uses this, but it's still good to know both versions. The question is now, how do we know what number to divide by? How do we know how many duplicates there are? Well, once we've chosen the 3, we can essentially figure out exactly how many duplicates there are by doing 3p3. So we can once again write 6 choose 3 as 6 permute 3 divided by 3 permute 3. And if we were to write this completely out using the factorial notation, remember that 6p3 is 6 factorial over 6 minus 3 factorial, and 3p3 is 1 over 3 factorial. So this is, if we write it completely, 6 factorial over 3 factorial times 6 minus 3 factorial. In general, we can write NCR equals n factorial over r factorial times n minus r factorial. Alright, so now let's do an example problem with combination. Let's say there is a 10-person class, and we want to choose a student council from this class, and they're going to elect 2 people. So we're choosing 2. If we plug it into the formula, then we have 10C2, or we can write it like this, and using the formula we would get this would equal to 10 factorial over 2 factorial times 10 minus 2 factorial. So we can see that most of 10 factorial, and this is equal to 8 factorial, we can see that most of 10 factorial and 8 factorial will cancel out and only leave us with 9 times 10 in the numerator. So this becomes 9 times 10 divided by 2, which is just 45. Alright, finally, let's combine permutation and combination into one problem. Let's say there is a 30 member club, and they are now choosing an executive council. So they are choosing 1 president, 1 vice president, and 2 executives. How many ways can they do this? Well, first of all, there's a couple ways that we can actually calculate this. So let's go with the way that I would probably do it. Now what I would do first is I would choose the 4-person executive team. So first of all, I'm going to choose 4 from 30, so that I've got my 4 people that will be on the executive team. So 30 choose 4. Then I'm going to multiply that by 4p2. So from the 4 that I've chosen on the executive team, I'm going to choose 2 to become president and vice president. And because it's permutation, I do care about the order, and therefore I do care about who's actually president and vice president, because there is a difference. Now we can go ahead and calculate this. 30 choose 4 is 30 times 29 times 28 times 27 divided by 1 times 2 times 3 times 4 times 4p2 is 4 times 3 times 2 times 1 divided by 2 times 1. So a lot of things we can cancel, and you should be left with and 29,000. There you go. Thank you for watching this video. I really appreciate it for watching, and stay tuned for future videos that are coming out. If you enjoy what we do and if you found this really helpful, please leave a like and subscribe. Thank you.